Hello, welcome to the session. My name is BJ Hargreave. I'm a open source developer in IBM Research, and I'm part of the IBM Granite team. And so that's what we're going to be talking about today. So first off, what is Granite? Let's talk about that. So Granite is IBM's family of open and trusted AI models that punch well high in their weight class. They have a couple of attributes that make them particularly useful in an enterprise setting, right? They're open, available on an open source license. We're transparent about the training data methods we used and the particular data, so reducing risk. They're efficient, they're fit for purpose. They come in a variety of model sizes, which lets them scale appropriately for certain workloads. In fact, some of the models are all small enough to fit on your GPU, and with quantization, you can even run them on laptops and other smaller workstations. And the models can be trusted, right? So we built guardrails in, and because of the carefully curated training data set, we can offer IP indemnification, which I think is important in a lot of enterprise scenarios. So Granite really represents a family of models. So there's a variety of different models here, and they have different purposes, right? So we've got the language models, which I guess is what most people are probably familiar with, sort of the GPT sort of things where you talk to it in words and it responds in other words. So we have several different variations of that. We've got an 8 billion parameter instruct-tune model, as well as a 2 billion parameter instruct-tune model. We've also got a couple of mixture of expert models. And so the unique thing about those is that you only use a subset of the full model weights to answer any particular question based upon the prompt you're given, right? So there's a 3 billion total, 800 million activated per prompt, and 1 billion with 400 million activated per prompt. So these are quite interesting and useful in sort of more resource constrained scenarios, perhaps even embedding in small devices. We've got Granite Guardian models. So these are specially trained models that sort of sit between the user and the language model that can help analyze the prompt as it comes in, looking for safety issues, attempts to hijack issues. And it can also analyze the response from the model on the way back to the user, trying to find things like potential hallucinations. And so these are good companion models to your LLM to help you make sure they're operating in a safe manner for your use case. Granite also offers a time series family. So we've got these time series models, which are quite small and efficient and are very good at generating forecasting data based upon past data. And we'll touch upon that in one of the recipes when we get to the labs. And then just recently, we've just released a set of embedding models. So if you're doing things with RAG, embedding is an important part of that. You've got to take your documents, chunk them, and embed them appropriately. And so we've got a family of embedding models depending upon your needs. We've got a nice small 30 million parameter model, English only. We also have multilingual models that support other languages as well. So the workhorse here is 8B instruct. So this is an 8 billion parameter model. It's been instruction tuned. If you look at sort of the benchmarks against its peers, it does quite well, slightly above, but it's basically well suited for its workload at this size class. Key thing here is it's small enough to fit on a single GPU or to run locally on your own system. 12 trillion tokens of high quality curated data have been used to train it, and the model is open source. So it's really useful for a lot of different tasks, language tasks. We'll look at the summarization and a RAG example as we go through the labs in this workshop. It has multilingual support, so it supports some of the key languages that are needed. It's got some code features, so it can do some code generation, and this will continue to be improved in the future. And sort of one of the key things that's happening with the agentic workflows is it's got support in it for agents, right? It's got function tool calling, multi-step workflows, and a longer context length, which is important. The Guardian models are, as I mentioned, are important for this in between the inputs coming into the model, analyze those, and also looking at the output of the model, analyzing it to make sure that there's no inappropriate or undesirable outputs from the model. So the Guardian models are quite small as well, and quite performant and do quite well in their job. Time series. So we've got a couple of different time series models, and they're quite small. As you can see, that the release 2 of the TTM model, the tiny time mixer model, is 1 to 3 million parameters in size. So they're quite small and fast. You can run them quite well on CPU-only environments. You don't necessarily even need a GPU. And they've been pre-trained on several hundred million examples, and there's 3 variations of it. And so it can take in 512 past examples and predict the next 96. And it's got a bunch of other interesting features as well. So it's quite unique and interesting for particular needs you might have around forecasting the future. So now what we're going to do is get into the workshop. So basically, we've got a workshop where we've sort of selected a set of recipes that we have around Granite and the various models in the family. And we're going to go through a couple of those. So if you can and you want to follow along on your own laptop, please do. The first link will take you to the workshop page where we're going to start. The second link is just the source code for that in the GitHub repo. So let's go to the workshop. So the workshop, basically, you can run this along with me here while we're doing this, or you can do it at your own leisure later. It should be fairly well explained for you to follow along. And we're going to go through 4 different labs here, sort of using Granite and companion libraries in the Gen AI space to solve a few small problems. And play with Granite and get some experience. So one of the key technologies we're going to use here are Jupyter Notebooks. All these labs are in the format of a Jupyter Notebook. So if you're familiar with that, great. And if you're not, it's pretty easy to deal with. To make things sort of simple for us, we're going to use Google's Colab service to actually run the notebooks. And we're also going to use Replicate as our AI hosting provider. And Replicate was one of the partners with IBM when we brought Granite out. But you can also run it locally with Ollama on your system. You have a choice in how you want to do this. And, today I'm going to go through using Replicate in Colab because it's pretty straightforward and simple. But if you want to play around with it on your own system, by all means, get Ollama, pull down, get the Granite models into it and use that. So, and as we go through these, I really want to try and make it as interactive as we can. So please ask any questions if I don't explain something well enough or I fail to explain something important that you're questioning. By all means, enter a question into the chat and our moderator will get it on to me. I'll just have to keep looking over at my other screen to see if any new questions come in. And I want to try to answer them sort of as quickly as we can and hopefully keep you guys spinning along. So the first thing we need to do in the workshop is basically make our decision. We're going to run our notebooks locally on the computer, or are we going to run them in Google Colab? As I said, for here, I'm going to run them in Colab because it's pretty easy and straightforward. If you're going to run them locally, you need to have a few more prerequisites. You got to have Git and Python installed at the appropriate level. And then you've got to decide whether you're going to use Replicate or Ollama to run your models. In our scenario, we're going to run the Granite notebooks remotely in Colab. So we got a couple things we got to set up. We got to make sure we're good for Colab, and that's pretty straightforward because all you really need for Colab is a Google account, which I'm pretty sure most everyone probably has one of those. To use Replicate, you need a GitHub account to do that. So it uses GitHub to authenticate with you. So I've got a Google account, I've got a Replicate account, but it's pretty straightforward to set up. If you just go to replicate.com, it'll ask you to log in with your Google credentials, and then you can create an API token, which we'll need for run the models, to authenticate back to replicate. Now, the other thing that you'll note here too is in this step, there's a nice little link here. So once you set up your replicate account, you can click on this link and it'll add a small amount of credit to your account. It's just, it's not a big number, but it's more than enough to run one of these recipes that we're going to go through. So for me running it here, I'm all set up. I've got my Google account. I'm logged in, so I can use Colab, and I've got a replicate account set up with an API token that I've configured into my environment, or actually into Colab as a secret. So when we're ready, now we can go to the first workshop. So the first workshop we have here is basically a text summarization use case. So basically, sometimes we have a lot of text and we need to summarize it, but it's a lot of text. So we can't necessarily do it in a single pass through the LLM due to things like context length. So we want to figure out how to break it up into shorter pieces and then combine the summaries. And so that's what we're going to do in this particular notebook. And we're going to use Colab. So let's fire it up in Colab. And so this opens up the notebook, the Jupyter Notebook that's in our GitHub repo straight into Colab. If it's your first time, you'll need to go into the little secrets key over here and make sure you set up your replicate API token that you created when you set up your replicate account. And the directions to do this are in the pre-work stuff in the workshop, so you can follow along with that. So we've got it set up here, so we're good. So we can close that, and now we're going to basically go through the notebook. So if you're not familiar with Jupyter Notebooks, they're very nice for learning things and exploring things and playing with things, because they're basically this nice mix of textual information and executable code right here. So we basically, you have a bunch of descriptions, basically what we're going to do, some stuff, and then anytime we get a block like this, we have code we can run. So we can just go over here, hover over the play button, and then run the cell. So this basically is just a little check to make sure that we're using an appropriate version of Python, and we get a green check mark, 0 seconds once it's set up the machine, and so that says we're good to go. We got a good version of Python. Now, like any good software, there are dependencies. You need to have the right things installed. So we have a step in each notebook that installs the necessary dependencies for that notebook. In this case, we're going to use a couple of different APIs. We're using LangChain as our sort of API for interacting with the model. We also need replicate, and we're going to use Dockling as another library to help us solve the problem here we have with summarization. So this is going to grind away for a few minutes, installing, and at some point we get to the end and we're all installed. I think we can skip that. Okay, so now we've got our dependencies installed. And so this basically, again, I mentioned you can use Llama on your local system if you want to run the notebooks locally, or you can use Replicate as the AI model hosting provider. Now you can use Replicate either if you're running the notebooks locally or if you're running them remotely like I'm doing them here in Colab. So basically that we got the code set up here so that it basically it looks for Llama, and if there's an Llama server there, it'll use Llama to run the notebook. Otherwise, it'll fall back and use Replicate. So here in this scenario, I don't have a Llama running inside of Colab, so it's going to use Replicate. And in particular here, we're using the Granite 2B model. So this is our very small language model, 2 billion parameters. We got a few arguments to the model, and we're passing in our API token out of the Google Colab secret. So this runs pretty quickly because we're just setting up the model, and it tells us it found our API token in our Colab secret that we had set up. Right, so the book here we're going to summarize is an older book called Walden by Henry David Thoreau. And we're using the book from Project Gutenberg since the book is old enough that it's in the public domain, so we don't have to worry about any copyright issues, etc. But it's a big book, right? Walden is approximately 650,000 characters long, which is it's too much in and of itself to pass in a single prompt to an AI model. So we need to basically break it up. And we need to do that in a meaningful way, right? So we're not just doing splits in the middle of sentences. And so we use Dockling to help us solve that problem. One of the other things we'll need to do is in order to understand our token count, we're going to need to load the tokenizer that's part of this model. So in this scenario, we're going to Hugging Face. We're getting the tokenizer for that model name. And so this takes a couple seconds to download from Hugging Face. There we go. So now we've got our tokenizer. So what we have here is some code basically that uses Dockling. So Dockling is a very cool open source project, also from that was published by IBM. And Dockling basically understands a variety of different document formats and some semantics about them, and basically is a great way to take these different document formats and ingest them into a standard format. And then you can take that and further use it and do other things to it, like chunking. So that's what we're going to use here to address this particular use case, the summarization use case. So we got some code here that does several things. One is we're going to basically create a converter. We want to use a hierarchical chunker, which understands the hierarchies in documents like an HTML file. And we're going to chunk it. And then we're going to basically, the final step here is we're basically going to throw away the front matter and the back matter so that we just have the parts of the document we want, since there will be some parts in there we don't necessarily are interested in. And then the next piece basically says, well, we've chunked this document up, but we really want to summarize units. And in this case, our unit is a chapter. So we really need to then take the sub-chunks and recombine them at the chapter level. And so at the end of all of this, we'll end up with a sequence of chapters out of the book. And so we have the drop while, which basically throws away the parts of the book before we get to Walden. It throws away once the next heading is not present. And we're going to chunk things at the chapter H2 level in this case. And so this is going to open up this HTML file here. So it's from Project Gutenberg. So you can see there is a bunch of front matter here that we really don't want to summarize. We want to just focus on the book. And there's also a little companion book at the end that we're not interested in either. So we want to just summarize the parts between there. And then we'll figure out how big the biggest piece is in that. So let's let that run. It's pretty fast. It's going to go pull down the HTML, understand it into Dockling's format, and then process those chunks and recombine them. And you can see that did that all in a few seconds. It ended up creating 18 chapters, which I think is actually what's in the book. But you will see that the biggest document in there is 38,000 tokens. And so that requires that we have a sufficient context length in the model, which Granite 3.1 does have. It has a 128K context length. So now we've got our document that we want to summarize. We've chunked it into chapters. Now we need to summarize each chapter. So we write a method here to help us. It's going to use the chat template for Granite and a supplied user prompt along with a collection of documents to actually generate the model prompt. And it will, just for some input and output, we count the inbound token size and the outbound token size of the response. And now we're going to chunk the chapters. So we basically say, using only the chapter document composes a summary of the chapter. And so this is going to iterate over each of the documents and ask the model to summarize it. So we can see it's working its way now through the chapters in the book. There are 18 of them. It's going pretty fast using our 2 billion parameter model. So we'll give it a second to finish up the work here. And when we're done, we're going to end up with a summaries object, which is basically going to be in a list of the various summaries. So we're going to go from 18 chapters to 18 chapter summaries. And then the final thing we're going to do is then take those 18 chapter summaries and then further summarize them as an aggregate. And so that's what the final step will do for us. So here we're basically going to prompt the model. It says using only the summary chapter documents, which we're going to provide, give us a unified summary over the entire document. And there we go. That's finished. So we've got 18 summaries created. And now we go back and ask the model to summarize the summaries. And so here we get a nice story. In Walden, Henry David Thoreau chronicles his solitary life in Walden Pond. And so if anyone is familiar at all with the Walden Pond, this seems a pretty accurate summary of the various topics discussed in the book. So that was a pretty interesting thing. I think we basically, through this lab, we've learned how to chunk things up with Dockling into an appropriate hierarchy, such as chapters, and then pass them into the model in sequence, and then finally do an aggregate summary using the model prompt. So hopefully, if you had the opportunity, you could follow along with this and use it yourself. If you have any questions, let me know. And otherwise, we can sort of get ready to proceed on to the next lab in our workshop. Okay, next. We're going to talk about RAG, Retrieval Augmented Generation. And so this is a super popular way of using LLMs because it exploits the fact that you can provide data in the prompt to the model, that didn't exist at the time of the model's training. Certainly in an enterprise scenario, almost no model has been exposed to all of the data that an enterprise has, all the information, because they're typically trained on public data sets. And so RAG is a way to use your enterprise information with an LLM to produce good answers to questions you might have. So we're going to play around a bit with RAG here in this workbook. So off we go again to Colab to open our notebook and start using it. Like before, we'll just confirm we have a good version of Python. And that's good. And let's get our dependencies installed. So one of the things about the RAG scenario is that we have a couple of other dependencies we need to use to do that. One is we need a vector database, right? Because we're going to take corporate enterprise information. We're going to have to put it in a vector database so we can find it when we need to be responsive to a prompt. And of course, putting information into vector database requires that we have an embedding model so that basically can turn a sequence of text into a vector of numbers. And that's what goes in the vector database. And then when a response, when you need to produce some documents that are responsive to a certain prompt, you again use the embedding to embed the question, and then the vector database will do cosine similarity searches to go find responsive documents to the prompt. So we got our dependencies installed. Again, all of these notebooks support using either Llama or Replicate. We're going to use Replicate here today. And now here where we're going to use one of the new Granite embedding models. Right. So since we need to have an embedding model to handle our vector, to use our vector database, we're going to go to Hugging Face and pull down our compact 30 million parameter English only embedding model for this lab. So it takes a couple of seconds for Hugging Face to deliver. Bump, bump, bump. There's our files down. So now we've got an embedding model ready to use. So the other thing, as I mentioned, you need a vector database. This is where your documents are stored along with their embedding. And so in this example here, we're using Milvus. We're using the LangChain library that wraps around Milvus. So we're going to create a vector database, add a temporary file location, and we're going to supply to it the embeddings model so it knows what the model is for the embeddings that we're going to use here. So this is pretty quick to set up. So now we've got an empty database ready for us to go. And like before in the other notebook, we'll look for OLLAMA if you're running it locally and you have a local OLLAMA server. If it doesn't find one, then it will use replicate. And again, we're using our 2 billion parameter Granite 3.1 model. Done. Okay, so now we need to get some text. What is our document? So in this particular lab, in this recipe, we're using a presidential State of the Union address dated back in 2022. And so this is going to go pull a file down off the internet, which has this text in it, and we're going to then have that available for us to use. So this is pretty quick to download. And in this notebook, we're not using dockling, although we could have, but we basically are just using a more simplistic text splitter, basically trying to split these things into, no more than 1,000 characters per chunk. And so this will give us a set of documents that we can then use to populate the vector database. And finally, we add them to the database. This is fairly quick. So we basically, these number here represents a document that's been added to the vector database. So now let's test it. So we have a question, or query, right? What did the president say about Ketanji Brown Jackson in that State of the Union address? So there's our query. We're going to pass it to the vector database. It's going to take the embedding of that query using the embeddings model, do a cosine similarity search against the other documents, embeddings that are in the database, and give us some documents that are responsive to the query. Right. So we can see here, this first one document does mention Ketanji Brown Jackson. So that seems like it's good. And so now we're going to use LangChain's support for building a RAG pipeline. So this got several parts to it. One is there's the prompt we want to use with Granite. And so we're defined a Granite prompt here that says use the following piece of context to answer the question. The question is going to go here as an input. And basically we build a prompt out of that text. We then create a document chain. So this is going to, using that prompt and the model, it's going to be able to add another element to the chain. And finally, in the RAG chain, we add the vector database in, right? So this is going to be able to take the input to the query, collect responsive documents out of the vector database, and insert them in the context spot inside of the prompt. And so here, when we invoke the RAG chain that we built above, our input, which is the question, is going to be, what did the president say about Ketanji Brown Jackson? And we'll ask the model, and oops, I forgot to execute the cell. It helps if I run all the cells. There we go. So the answer is the president announced that he had nominated the judge Ketanji Brown Jackson to serve on the United States Supreme Court. So that seems like the right answer to that question. So that's a very simple RAG example using LangChain, using Granite embeddings, using a vector database, and then using the Granite 3.1 model to do the processing of the selected documents and answer the question that was supplied in the prompt. So if there's any questions about that, please enter them in the chat, and I'll try to answer them. Okay, so we got 2 of our 4 workshops done. What's next? Time series forecasting. So we got another nice notebook we can use in Colab. This one's got some pretty pictures in it with plots. So it'll be interesting. So basically the example here is energy demand forecasting, right? So these, the Granite time series models are tiny time mixers. They're basically very small models pre-trained in the topic of time series forecasting. And these are also open source like the other Granite models. And so we want to be able to use these to do some sort of interesting forecasting. Like everything, we've got to install our dependencies. So this will go pull down the dependencies of the time series forecasting models and install them into our Colab environment. And then after that, we're going to import the various packages we're going to use. We're going to use some plotting support from Matplotlib, some Pandas support, as well as some types and methods from the time series forecasting model library that we're installing now. Okay, so basically we need to go pull in some types we're going to use in our model, in our lab here. So this is going to load those up, and now we're going to go look at the data source. And so in this scenario, in this lab, we're going to use some historical data that was gathered in Spain. And so it's got some electric demand generation by type along with some other information. And so this basically is going to be what we're going to use to do our time series forecasting. So we're going to go pull this data file down from Hugging Face data set. And we're going to specify the things we're interested in, right? So we're going to say the name of the timestamp column so we know when things are happening. And the target column that we're interested in is the total load actual column of the data set. This model supports a 512 context length, so that means we're going to take up to 512 data points as input to do the forecasting after that. So now let's go read some of this data in. So we're going to pull the data in from the Hugging Face data set, and then we're going to basically take the last 512 elements of that for use in our prediction. And just to show what's in there, we're just going to show the tail of the data. So here's a couple of examples of some of the data that's in the data set. We've got time, of course, which is interesting, and a variety of other things, which in particular, we're not going to care about much here, but the thing that we did care about is the total load actual. So let's plot that data, right? So using that data, we can show how energy demand waxes and wanes over time. And now we're going to use the tiny time mixer for prediction to then go predict stuff. So we're going to pass in, select the model and the target columns that we're going to use. And so this was the total load actual. So this will pull down our little model here and instantiate it. And so now we want to create a forecasting pipeline. We're going to use the model, tell the timestamp and target columns, and we're just going to use the CPU since this is pretty efficient, and it's going to generate a forecast for us. And so now we can go plot that forecast and see what it looks like. And so basically, it will show the historical data in blue. Here's time when the data ended, and then this is the prediction for the next so many epochs of the time series. So it's pretty interesting. You can see how the curves follow well the previous curves, and so it's quite interesting depending upon your scenario for doing forecasting. And it's super small, so it can be used in a lot of different environments, including some embedded type environments. Oh, I see there's a couple of questions that have come in. How does the Granite family handle cross-modal interactions, such as combining language and time series data for more complex insights? I think I don't know that there's a one model that rules them all sort of scenario there, right? Because the time series data is really about doing sort of the predictive future things about a series of data that's in series time. Whereas the language model is much more about processing language. Now you could sort of use one to generate data to feed into the other. Probably more likely time series data. It could be processed into textual information that a language model can then explain. But I don't think there's one model that would do both of those. Can you use this forecast sales based upon a data set of old sales? Probably, yeah. If there was information in there that could help correlate, right, in order to predict the future, then you could certainly do something like that. There are some other time series examples up there in the Granite Cookbook, IBM Granite Community GitHub repo. Check them out. Also go to the ibm.com/Granite website and find the time series stuff, and there's pointers on there to lots of other examples and use cases for the time series. What is the best practices or strategies would you recommend for integrating Granite models into existing workflows, particularly for industries like healthcare or finance? I don't know that there's a specific strategy. I mean, it's a large language model. You'll need to have it hosted in some place. One of the nice things about Granite, of course, is it's open source, so you can do with it as you wish. You can host it yourself, particularly if the information is regulated, like in healthcare or finance. So it's nice, you don't have to send your data across the internet to an AI model hosting provider if you can host it yourself internally. And because Granite is reasonably small, it can run on a single GPU, it's much easier for you to actually do that without having to have complex systems to run super large models. Is anything LLM helpful? Can we use it for this use case? Yeah, I mean, anything LLM, I think if you saw the prior session, Brad Topol did a quick demo of that. It's quite useful for playing with things, and it understands the RAG use case. So it can be useful for that and learning and practicing. I'm not sure you'd want to do that necessarily in production scenarios, but it's certainly a great prototyping and playground to learn things. Okay, so let's move on to our next lab. Okay, we did that. And so this is generating some bash code. So prior to Granite 3.0 release, we had a number of Granite models. We've got Granite code models. And this is using one of those Granite code models. That's our anticipation that the newer Granite 3 models will eventually be as good at or better than the older Granite code models, but this particular lab uses the Granite code models. We, at some point soon, will have to update it to use the newest Granite 3 stuff. So let's fire up Colab again, as we do, and run this model here. So this is a fairly simple story where basically we're just going to have it using textual descriptions generate some bash code for us. Got too many sessions. Let's kill some of these old ones. There we go. Okay, now we got to get our dependencies installed. All right, and so in this case, right, we're going to use the Granite 8B code model. So again, if you are running Olama, want to run it locally, we'll use that version. If there's no local Olama server, we will go to Replicate and use the Granite 8B code instruct model that's up on Replicate. So let's get our dependencies all installed. Okay, good. So let's get ourselves a model object. Right. Okay. So the example here, we're going to need to have a bit of information, right? Since we're asking to generate bash scripts that use commands in the operating system, sometimes different operating systems are different, you know, go figure. But, and so here we need to figure out where we're running DOS or Mac OS or Linux, and we need to figure out what that is. So in this example here, since we are running it in Colab and not on my MacBook, the answer is Linux, right? This is a Linux operating system, and it's using the bash shell. So that's what we want to generate. So here we basically have a prompt where we're going to ask the model to generate some code for us. And so it's going to generate a bash script to do a certain thing. And so here's what the model decided. So here's a bash script that does what you want. It generates this code here and provides an explanation. So let's go, the question is then, does this really work? Let's try the script. So we can go down here and paste in the code that just got generated up here, and we'll see what we get out of it. And so we see that there's a bunch of files. There are less than 50 of them. They're modified pretty recently in the last few days. So it seems to basically look like it's working. So that's good. You can also do other things, right? So that was a zero-shot prompting, right, where we basically didn't give it any examples. We just asked it to do it. You can also do few-shot prompting as well. And so in this case here, we're going to provide it a couple of different prompts and answers to help it along. We're going to, since again, operating systems are different, we need to figure out what the right arguments are to the stat command, which this does, and then we'll define a few examples. And so this using LangChain also helps us build our prompts out, right? So we've got a chat prompt template and a few-shot chat message prompt template. So we basically can build an example prompt parts, and then we can expand that out across multiple examples, and then add that into the final chat template, which asks the question. And you can see there's only one variable that we need to provide, and that's question. So here we can see what the prompt would look like. It basically you can see it uses each of the few-shot examples and then follows it up with the instructions, which is show me a bash script, blah, blah, blah. Let's run it, see what we get. So we get another little bash script here. So we can try that out and see how it works. Copy that, we'll go back up here. Paste it in here. So that gives us, it looks roughly the same answer, just a different format this time. It uses the ls-l command to show the time information. So basically similar. And then the final example here is we're going to take that from above, the few-shot prompt we built above, we're going to add a system prompt to it. And we'll run again. And this looks very much like the example we had before. So this looks good too. So this is just a simple example of doing sort of text descriptive prompting in order to get some code out of the code model. And there are several other of these examples up there. In fact, there's a great effort was done using the Granite code models to basically add your own private Copilot-y sort of thing into VS Code. It's very interesting. All right, we got some more questions here. In your session, you mentioned the Granite models and their wide range of applications. I wanted to ask if it's okay to use the quantized models from repositories like the bloke on Hugging Face. Yeah, so we recognize that this is, people need to use quantized models. In fact, if you use Olama and you pull the Granite models down from Olama, those have been quantized by IBM to provision them up to Olama. We're currently working on putting together a system so that IBM will put out the quantized versions of the Granite models on Hugging Face. That's still under development, but hopefully we'll get that going shortly, and then there'll be sort of more canonical quantized model versions that people can pull down from Hugging Face. So that's coming. That's all the questions. So I think we pretty much got through all the questions that we have. I want to thank you for coming today and enjoying this. Hopefully you'll get a chance to go to the link to the workshop. And if you haven't already gone through it yourself, following along with me, that you'll go through at your leisure and learn some stuff and try Granite out. It's pretty nice. It's fun. I encourage you to try it with a llama on your local system if you can. Otherwise, go ahead and use it on Replicate. Thank you very much.